Good evening, everybody. We're going to be talking about making an impact. As you can see here, how asteroids and comets have helped create, destroy, and preserve life here on Earth. And hopefully we can maybe you'll learn a little bit of something, and I'll be able to guide you with that last part about preserving life on Earth. Okay, so the origin of the solar system has been a search for clues to planetary formation and the rise of life on at least one planet, of course, that we know of, Earth. Congratulations, you're standing on it. This is an overview of what we know of our solar system and the search for life's origins. The origin of the solar system actually starts here. A first generation star went supernova roughly about 5 billion years ago. This is a very much recent supernova back in the mid 1980s. The first supernova to be seen with large telescopes and such in the history of astronomy. This guy here was from the southern hemisphere, part of the Eta Carini nebula down the south. Okay. From the debris of that star exploding, the materials can create second generation stars. Our sun is the second generation. And in the process, form little bits of specks of dust and gas, what we call our solar system. Which, of course, we're standing on one of those specks of material right now. Okay. This is a wonderful, I always like this shot. This picture's got to be at least, about 25, 30 years old. I never tire of it because theory changes, but this is pretty much what we'd be looking at if we could go back about roughly 4.33 billion years ago with the newly formed sun, comets all over the place, lots of debris, and the planets. Okay, so currently, this is our solar system. And before anybody says anything, I'm one of the people that still says Pluto is a planet. Yeah. It's very annoying that they're saying it's because it's tiny. Well, it's round. It has gravity enough that if you weigh 100 pounds here, you weigh roughly about 23 up there. So and it is also on orbit around a star, the sun. But this is the idea of the relative sizes of the known planets in the solar system. So you can see it varies quite a bit. Most of the mass, of course, is in Jupiter, the sun and Jupiter, and then some extra debris. And we're standing on one of those pieces of debris right here. Okay. But you have to really run back away from the sun to get an idea just how large our solar system really is. Okay. Right here, Earth's orbit's here, Mars, the asteroid belt. Think of asteroids as pieces of rock and metal left over from the creation of the solar system. You jump back out, Jupiter's orbit's over here. We're almost 1 billion miles away from the sun at this point. Pluto's orbit's right here. And beyond that is a belt of debris, of ices and such called the Kuiper belt. And beyond that is the Oort cloud, which extends, we think, about a light year in any direction away from the sun. This is our domain for the time being. Okay. So I mentioned before an asteroid. What is an asteroid? It's a small body comprised of rock and or metal that orbits the sun. They're considered to be remnants of the solar nebula, the gas and dust cloud that form the planets. And most of the asteroids are found in the area between the orbits of Mars and Jupiter. This is a spacecraft photograph taken of asteroid 25143. It's Itokawa. If I remember correctly, there may be as many as like 80,000 already discovered. Some of them about the size of this building, many of them much larger. Okay, and how many asteroids are in our solar system? Several 100,000, we figure, have been discovered and given provisional designations so far, meaning the year, the month, the date, and then a serial number. Thousands more are discovered each year. We're running out of the ability to give each one names. Our language just doesn't expand that far. Okay. So you might ask, okay, there's always a time for firsts. Who discovered the first asteroid? On January 1st, first day of the year and the new century, 1801, In Palermo, this gentleman, Italian astronomer Giuseppe Piazzi, discovered the first and largest asteroid, 1 Ceres. The 1 refers to the order of discovery. Asteroids range in size from tiny little pebbles to about 930 kilometers in diameter, like 1 Ceres. At least 16 of them were over 150 miles in diameter. Some asteroids even have orbiting moons. Pretty much chips off the old larger asteroid. Okay, and here are the largest ones. Witzgall over here. 1 Ceres, where we get the word serial. That's where it comes from. 2 Pallas, 4 Vesta, and 10 Hygienia. You can see the size in kilometers. The very first one, as I mentioned before, 1 Ceres, was discovered on January 1st, 1801, pretty much start century, by Piazzi. 2 Pallas, 4 Vesta is especially interesting, at least to me. Discovered back in 1807 by Olbers. It's an interesting object because it appears to be made out of volcanic materials. Now, it's too small to have volcanoes, but maybe it was a melt from a collision somewhere. Matter of fact, photographs of it do show some heavy cratering there. Okay, there's 1 Ceres, the first one. This is a spacecraft photograph. And it gives an idea. I mentioned before Vesta, there it is, taken by spacecraft. And Ceres, Charon, which is a moon, the largest moon of Pluto. Pluto would make a terrific small planet, and everyone's trying in the last couple decades or so. I've been trying to demote it down to a dwarf planet. No such thing as a dwarf planet. It's a planet or it's a rock, an asteroid. This is not an asteroid. Okay. And sometimes they have companions. This is 243 Ida, and its satellite, Dactyl, it's about a mile across. This is about 35 miles by 15. And it may be a chip off this object here. As you can see, there are a number of pits across. Those are created by small meteoroids that come in, hit it, knock off material. But apparently, Ida was able to hang on to one rather large piece. Okay, and here's a really weird one here. This is asteroid 25143. That's that's the order of discovery. Itokawa, one of the oddest looking asteroids you'll find. It's about 3 miles long, no real visible craters. It's probably a rubble pile, and it looks like 2 rubble piles came close together and kind of merged a little bit. I'll bet if you stood there, you could probably have enough force in your space-suited boot to kick rocks off and away from this object. That's how weak the gravity probably is. Now you might ask, okay, great, Al, what are asteroids made of? There are 3 major types of asteroids. C-type, which are carbonaceous, made of ancient carbon silicates. It might be a precursor to chemicals for light, for example. S-type, which are silicates, kind of like quartz and other materials, made of stony silicates, some iron. And then N-type, which are metal-rich, mainly nickel and iron. This is a C-type out of my collection. This one fell in a place called Murchison, Australia, back in 1969, I believe it was. Okay, and where would you find asteroids? The area of the solar system between the planets Mars and Jupiter is where the greatest population of asteroids can be found. Now, don't fall into the illusion that they're so packed in here. They have something like there was a scene in one of the Star Wars movies where the Empire is going after the Millennium Falcon, and it's chasing it, and there are asteroids all over the place. And it doesn't work that way. There's quite a bit of distance between all these little things. And interestingly enough, group families of asteroids occur. Trojans, if you've got Trojans, you have to have Greeks, which are ruled by Jupiter gravitation. Little poetry here. Okay. Now, I just threw this in here because I rather enjoy this. I have a collection of meteorites at home. Don't bother breaking in. They're too small to be worth anything really much. But some of them are of this type. They may have come from an object like this. An OSIRIS-REx spacecraft studied this asteroid, which is named Bennu. Okay. This was the first spacecraft to orbit an asteroid, OSIRIS-REx. And you get an idea of how scale. If you've seen a photograph of the Eiffel Tower, this is how big this object would be next to the Eiffel Tower. It orbits the sun roughly every 1.2 years. It's anywhere between 100 million and 1 billion years old. We're not completely sure on that. We did see a lot of large bulges. We're not sure why that happened. Maybe it picked up something from elsewhere. This is an overview of the rendezvous the spacecraft made with it, took samples and came back to the United States in the Southwest. But I think this wasn't very friendly. This vehicle traveled almost 500 million miles to get there, and what happens? For some reason, the asteroid's throwing rocks at it. I'm not kidding. There's little pieces that have come off. Maybe the maneuvering jets on the spacecraft may have kicked it up, but it just doesn't seem very friendly. And it did have a sampling mechanism. There we go, which allowed it to impact carefully and slowly take a sample. Came from here. This is at the point of contact. You can see it's been processed. This is the underlying material. It has false color, but it did get a sample. And maybe it did a little too well because apparently it was too full, and you can see the little particles around it here. It's actually leaking samples. I'm saying to myself, I'm panicking, saying, you never know. The secrets of planetary formation is on this object that's getting away. So, in their infinite wisdom, they very quickly sealed it up, packed it up, put it into a return capsule, which came back to Earth, returned on September 24th of 2023. And it landed perfectly, did not open up. This is not one of these science fiction movies where the spacecraft comes out and it breaks open or something happens or somebody deliberately opens it and some icky, evil thing comes out. The blob. It don't work that way. It doesn't work that way, folks. I'm sorry. We're probably in a nature preserve because we're too primitive for the rest of the galaxy. But this is the recovery package. It landed perfectly sealed. Beautiful piece of work. And then there's the return when the daylight, because it landed just before sunrise, had sealed it up. And in the laboratory, they opened up the container. These are all the materials that were found within it. First time we ever sampled an asteroid. Okay. There are others which usually follow, in this case, Jupiter. Asteroids orbiting a gravitationally stable Lagrange point. Mathematically, you calculate, the mass of this planet, you can figure out what can be put ahead of it and behind it. In this case, either trailing or preceding it. Okay, this gentleman here discovered it. This is Max Wolf, back in 1906, the largest Trojan asteroid known as Hector, which is out by Jupiter's space. And thanks to our better infrared telescopes, we found it had, like many asteroids, it had a companion, Scamandros. Discovered in 2006, it orbits Hector in around 16 hours, so it's got its own personal moon. Okay. Then other small objects. These are the ones that are the most exciting, pretty much to just about every astronomer I know of, as well as, of course, the public. They're relatively rare, and it's getting rarer, not because you can't see them because they're not bright enough, but our cities drown out with its light pollution, drown out even some of the brighter objects. A comet is a small member of the solar system made up of rocky material held together by frozen gases like a dirty snowball. 80–90% of it is made of gas and water. 10 to 20% are leftover chunks of metal and rocky material from the solar system's solar nebula. Orbital periods can be as low as 3 years to millions of years. Okay. It's comprised of a nucleus, a coma surrounding gases, and two kinds of tails. The nucleus is the solid center of the comet, and this is the ice ball that actually, when it heats up, starts to. Uh-oh. What happened? May need some help over here.
Probably have to click on the slideshow, right?
Yeah. Okay, hang on.
Yeah, just put it in the slideshow.
Yeah, that's a surprise because I didn't even touch it. Maybe
It's
I
a
can do
computer.
this. Maybe I have powers of moving. Anyway, a comet comprised of nucleus, coma, and two kinds of tails. The nucleus is the solid center of the comet. Okay, there we go. The coma is a dense cloud of water, carbon dioxide, natural gas, and sublime, heated off directly to gas from the nucleus, and the hydrogen cloud that surrounds it, very huge but very, very faint envelope of neutral hydrogen. Okay, this is the first X-ray, by the way, view of a comet. This is Comet Yakutake back in 1996. We marveled at this in the March sky, and it was taken by Rosat. And you can see that apparently the sun's over here and it's generating X-rays from the radiation of the sun. Really remarkable. Most visible and distinct features of comets are the coma and the tail, but most of that mass is contained within about a tiny little central nucleus. The largest comet, I think that's on record, the actual nucleus, is only about 25 miles in diameter.
When it came through, I got some shots from Jenny Jump at like 70-degree tail. It was really, really good.
Oh, wow.
Not a bright tail, but
it was a tail nevertheless. And you documented, that's great.
Yeah.
So now, of course, everybody says, okay, where do the comets come from? From several places. First off, the Kuiper belt, a gentleman by the name of Gerald Kuiper theorized that there was a reservoir of short period comets that every so often they get bumped out of the way. Maybe they collide with another comet. Maybe Jupiter's gravity reaches out and actually pulls them in. Disk of debris at the edge of the solar system and the source of short period comets. Okay, beyond that, this is the main source of most long period comets, the Oort cloud. Jan van Oort came up with the theory about this in the 1950s, and so far it seems to be holding pretty true. We are surrounded out to maybe about a third or a half of a light year by this cloud. Now, if you're familiar with Star Trek, they keep talking about deflector shields, especially when you're being attacked. Well, the deflectors you need if you're going to be cracking the speed of light, because they're going to blunder right into anything like this in reality. So, a little science in the fiction. Okay. It is a sphere widely spaced comets and dust up to 30 trillion with a T kilometers from the sun. Long period comets, random time and direction. This just gives a relative idea of the inner solar system to the outer solar system, the inner extent of the Oort cloud, the orbit center, and out. So it's very, for a place that's got a lot of space in it, it's got a lot of stuff in it as well. And this is just an artist's conception of a large body out there called Sedna. Okay. Most comets travel in highly elliptical orbits around the sun. Comets travel in regular orbits. The motions are dominated by the gravity of the sun and the major planets. You want to get down to it. Gravitationally, our solar system is nothing more than the sun, Jupiter, and some junk left over, and we're in one of those pieces. But they do quite a bit of an influence on the motions of comets. Okay. Probably the most famous comets. Comet Halley, 1705. Edmund Halley, using Newton's law of planetary motion, predicted the comet that was seen in 1531, 1607, 1682 would return in 1758. Unfortunately, he passed away, I think, about 10 or 12 years before that object came back. But sure enough, it came back as predicted and was named in his honor. And this is a photograph, one of the first photographs taken. I believe this was taken back in the 1860s, the time before 1910. It's very primitive, but the comet does show up very nicely. The average period of Comet Halley is 76 years. It's going to be coming up again in 2061. I think it's going to be in the spring of that year. So I'm hoping a number of people in here, myself included, are going to make it to that. Some of the kids here will. So put it on your calendars, ladies and gentlemen, boys and girls. You never know.
Unfortunately, the last time it was on the other side of the solar system when it came through.
Yeah, this time.
Didn't get any photographs.
Yeah. This time around, though, I got a couple pictures of it. But this time around, 2061 should be a reasonably good apparition. So that's a good thing to live for. I can't die now. I'm 91. I still got 10 years to go. And you keep on going. Maybe. Okay, Halley's nucleus. This is a photograph from the European Space Administration's Giotto spacecraft obtaining close-up photos of the nucleus. It's roughly about 16 by 8 by 8 kilometers. Density is very low, just a bit, about a tenth of a gram cubic centimeter. It's very lightweight, very fragile.
That would float, right?
You can, easily.
Yeah,
In water, oil, almost any material.
yeah.
And you can see where there are areas of activity on this very dark nucleus. Okay, and then some more recent comets. Okay, this is not a comet, obviously. This is the discoverer, however, of comet Hyakutake. Discovered it back in 1996, January 30th. Came 13 times closer to Earth than Hale-Bopp. And it will come back, if you're putting it on your calendar, somewhere between 10 and 20,000 years from now.
I will put that.
Okay. This is Hyakutake as we saw it. This is taken, if I remember correctly, the Boreas State Park. I got lucky. The plane containing its motion was almost perpendicular to the planet contains the Earth and the other planets. Means this guy probably came from the Oort cloud. This is my favorite of recent comets. Discovered July 23rd, 1995 by two independent observers, Alan Hale and Tom Bob. The farthest comet ever discovered by amateurs and appeared 1,000 times brighter than Comet Halley did at the same distance. This shows the nucleus, and with the 24-inch telescope over here, saw the nucleus, and we also saw the spiral cloud. I said that can't be right, but I put it in the drawing anyway and took a photograph, and sure enough, there it is. It's not the photograph I took, but it did show that kind of curve to it. There we are. Estimated to be about 30 to 40 kilometers across. Comets are normally inert when they are beyond the orbit of Jupiter. They cool down. So it's been speculated Comet Hale-Bopp was either a very large comet or experienced a bright outburst, maybe a little of both. Made it easier to discover. Okay. The closest approach to Earth back then, on March 22nd, 1997, was about 1.3 AU. That's 1.3 times 93 million miles, the distance of the Earth to the Sun. So it's reasonably close. And again, it's large size, unusually bright. Okay, from Voorhees State Park, I've done astrophotography quite some time. To me, this is the best photograph I ever took.
Al, you can see both tails.
Yeah.
Yep, that's right. Very good. It's the gas tail and the dust tail. This was a dusty comet. Trust me. It was taken on April 12th, 1997. Anybody remember film?
Yeah.
Ektachrome 1600, 3-minute exposure, the best of 4. I got lucky. I think the whole planet got lucky with this. That's beautiful. I got lucky. And then, of course, when we talk about comets and asteroids, you must talk about the dinosaur killer. Roughly 65 million years ago, as you probably already know, an object came in, probably an asteroid, maybe probably not a comet. We need something solid for this. Crashed off what today is the Yucatan Peninsula and caused a wave of destruction which wiped out the dinosaurs and about somewhere in the order of about almost 70% of life on Earth. Some of the survivors, however, eventually evolved to become us. So, dinosaurs 0, Terrans 1. Okay. Could this happen today? This is taken back in, if I remember correctly, this was 1998. This was an object that came within 57 miles of the Earth's surface. Nice and slow, and you could hear the sonic booms that was going through the air and bounced off the atmosphere. It's a shame. If that had hit somewhere, it may have probably left a crater, fresh crater, I don't know, about 10 miles across. Luckily, it bounced off the atmosphere and away. And you can see people down here at Lake Tahoe are looking up. So, as I understand it, it was like rolling thunder. Okay, and by the way, it has already happened. A bit scaled down, however. This was Chelyabinsk, Russia. On February 15th, 2013, this thing came in just before, just about really at sunrise, and you can see the dust cloud that it left behind itself. And this is a sample of one of the pieces. It's very characteristic of meteorites. The interior is kind of light colored, and it's got almost a black fusion crust, melted materials that came in the Earth's atmosphere. And one large piece had the nerve to land and penetrate through a nearby lake. Yes, they sent in divers after it. And it's still, if I remember correctly, it was almost a quarter of a ton of material. I have to look that up again. You can see how big that thing is. Okay, we traced out the orbit from many, many people. The bad news was that if you were a driver back then, the Russian government and police departments were making a killing, ticketing people for doing anything, for parking in the wrong place, for driving a tenth of a kilometer over the speed limit, or maybe a kilometer less than the speed limit. So everybody had a dash cam. The dash cams gave us lots of information from various places where they were, so they could triangulate from many, many sources so we get an idea of the Chelyabinsk meteor. And you can see it came within the orbit, close to the orbit of Venus, and then out. And of course, we intercepted up there, which was an amazing thing. Lucky dogs, they got to see one of these things and experience it. Okay. All right. Before I go to this, I'm going to divert one thing here. As far as Chelyabinsk was concerned, I got to give the Russian government real credit, because every window in that city shattered early that morning. But by the end of the day, either windows were boarded up or actually replaced. So nobody froze to death that night, because the average temperature when this fell at night was about -40. It's Fahrenheit. So I will give them credit. Okay. Yeah.
3/4 of the ton.
3/4 of a ton? Okay. I thought there was more to it. Okay.
Well, that was the big one.
Oh, okay. Okay. Now, a question. The age of the Earth was important if set to settle a timeline for the formation of the planets. This is very new to me. Claire Patterson lived 1922 to 95, worked to determine the age of meteorites, stones, and other metals from space, through the study of zircon, which is a very tough material, and thus date the formation of the solar system. In the process, he noted an excess of lead in the Canyon Diablo, which is the Meteor Crater, Arizona iron meteorite, and he traced it to the paint in his lab, lead oxide. Okay. He determined the age of the Earth, despite this, and the solar system to roughly about 4.55 billion years. That figure is still valid today. But his research traced the excesses in his study to lead paint in the lab on the walls and to car exhaust. He got a lot of trouble with a lot of car manufacturers and such, but the evidence was there, because leaded gasoline had been poisoning us for the better part of about 55, 60 years. The research traced it to the lead paint in the lab and in car exhaust. This helped the lab, and then, of course, in the world in general. I wanted to have this guy recognized here, because the laboratories are looking for such tiny, tiny amounts of materials, and he was able to show indirectly that we were poisoning ourselves. Now the environment, it's going to take a long time to get lead out of the environment, but this guy was the one who pointed the way for us. Not to mention making sure that his lab's accuracy stayed there.
Okay, back in the day, the manufacturer of Dutch Boy paint, the name of the company was National Lead.
Oh boy, that I didn't know. Oh boy. Well, that explains a couple things now, don't it? Okay. So in closing, nothing is so good as an experiment. Excuse me. Which will sets an error right, gives us an absolute advancement in knowledge. It's Mike Faraday. And I have to thank Bonnie, who keeps these things straight and make sure that, are you sure about that spelling on this? Yeah, I guess so. Mary, who allows me to give these speeches here, if you will. Dr. Mary Lou West right in front of me over here. By the way, thank you for giving me all that paperwork, a lot of information, and I'm going to go through it. It looks great. And Mark Zadarsky, a fellow geologist. And with that, I conclude my talk, and we'll take